All right, so we have an object projected upwards at an angle 56 degrees at a speed of 12 meters per second. That's a speed. Acceleration due to gravity is negative 9.8 meters per second squared, where negative is going downwards. Write down the acceleration vector. Well, this write down command is good IB term, so it should just be able to determine it without much calculation. So the acceleration, well, if I think about acceleration due to gravity, that's my y component. My x component is 0. My y component is negative 9.8. There is my acceleration vector. B part says to find the velocity at a given time. Well, we know velocity is the integral of the acceleration function. Well, we want to integrate this vector here, 9.8 dt. Well, that's going to be some constant, and this is going to be 9.8 t plus a second different constant. My dilemma, though, is I do not know what my constants are, so I have to think about this initial, what information do we know? We know that initially it's launched upward at an angle 56 with a speed of 12. So if I think about my objects thrown up at 56 degrees, and here's the ground, here's 56, and this speed is 12. If I make my components, this distance here is going to be, this is adjacent as cosine, so this is going to be 12 cosine 56. Because if I call this the x value here, I know that x over 12 is equal to cosine of 56. And so this x is 12 cos 56. Similarly, if I do the y value here, that's going to be the sine function because it's opposite. So this is 12 sine of 56 degrees. And so my initial velocity, so my velocity at time 0, because this is the initial velocity, is going to equal to, if I do 12 sine 56, I get 9.95. And if I do 12 cosine 56, I get 6.71. And so this can help me find my C's. And so what I can say is that if I want to find C1, I plug in 0. I'm going to say that 9.95 and 6.71 is going to equal to C1 and negative 9.8 times, because this is going to be the velocity at 0 plus C2. Well, I can see from here that C1 is equal to 9.95 and C2, that's 0, is going to be 6.71. So my entire velocity vector is 9.95 and negative 9.8 t, because here's where I'm looking at, plus 6.71. Looking at the next part of the problem here, it says at time t equals 1, the position is 9.95, 1.8. So now I'm looking for the position, determine the initial position of the object. Well, if I'm looking for the position function, I know that's the integral of my velocity function. Here's my velocity function, so that means I'm going to get the integral of 9.95 is 9.95 t plus some constant, I'll call it C1 again. And when I do the integral of this one, that's going to be negative 9.8 t squared divided by 2, and that is 4.9 negative 4.9 plus 6.71 t plus some constant 2. And so this is r at t. Again, I want to find my C's. And I can use this idea if R at 1 is equal to 9.95 and 1.81. So if I know R is 1, then I can say my X value is 9.95 is equal to 9.95 times 1 plus C1. I subtract it, I get C1 is equal to 0. Now if I do the second one, I get 1.81 is equal to negative 4.9 times 1 squared plus 6.71 times 1 plus C2. And when I do that as well, I get 1 plus 4.9 minus 6.71 is equal to C2. And that value is 1.81 plus the 4.9 minus 6.71. That is also equal to 0. And so if I put that together, I'm going to take this function. I'm going to take this. And so if I want my initial value, R of t is going to be 9.95t, C1 is 0, and negative 4.9t squared plus 6.71t plus C2 is also 0. If I want to find the angle that strikes the ground, I need my velocity vector. And so my velocity vector is here. I'll bring this down here. Here's my velocity vector. If I want to see when it hits the ground, like here's the velocity, it comes down, and it comes down. I'm looking for this angle alpha. I need to know the time it hits the ground. And so to find the time it hits the ground, that means I want my y value for position to be 0. So to find the time it hits the ground, I need my position, my y value for the position, y at t, to equal to 0, which is negative 4.9t squared plus 6.71t. Because when it comes down, it's y is 0. Up and down is 0. And that's when it hits the ground. Solving for t, I pull out t as a factor, negative 4.9t plus 6.71 equals to 0. So t could be 0. Well, that's when it starts. That's not doing that one. Or negative 4.9t plus 6.71 is 0. So t then will be the 6.71 divided by 4.9, and that is 1.369. So at 1.369, it hits the ground. Now I need to find my velocity at that value, at that point. The velocity at that point. To find out the impact, what's the vector going to be? To find the angle. So if I do the velocity at 1.369, I know my x value is 9.95, and my y value, when I plug 1.369 into here, negative 9.8 times 1.369 plus 6.71 is negative 6.71. So that means going down velocity is 6.71 negative. Going across velocity, that component is 9.95. And to find the angle tangent of alpha, I'm going to ignore the negative because I'm just looking at the distance, is 6.71 over 9.95. And alpha then is, if I put that in my calculator, second tangent, 6.71 divided by the 9.95, I get alpha to be 34 degrees. And so we use velocity to find out, we use the components of the velocity, the y and the x, to find the angle the arrow, the object approaches the ground. We need the time when it actually approaches the ground to find the actual velocity. And so in doing these problems, we really have to think about acceleration, velocity, and position and time for them all. And deal with, are we dealing with the x value or the y value of each part along the way?